Okay, for section 3.9, I will keep it short and sweet. It's a short section, it's not on the test. I want you to understand how to do these because I know for a fact that translations actually show up in several different areas outside of college. So I'm just going to two examples out of the book to help you understand. Number two, they give you the same coordinate plane with two graphs. The given equation is for the red line, which here is green because I didn't have red. So green on my sheet is red from the textbook, and they say that's y equals x squared. And if you graph the points, you see it. When x is 0, y is 0. When x is 1, y is 1. When x is negative 1, y is 1. X is 2, y is 4. X is negative 2, y is 4. We got a parabola. So then what they do is they give us a blue line, and they say, well, what's the equation of this one? And if we look at that blue line, we have, we go down here and there's a point at negative 2, 0. And we don't ever want to guess when we're in algebra, but this is one of those cases where we really are guessing at the equation. You want to always be able to prove things. But in this case, we look and say, well, it looks like it's going through 0, negative 2. Then it looks like we're over here at 1, negative 1. And it looks like we're at negative 1, negative 1. And then you can go up to where it crosses again, and it appears that we are at 2, 2, and negative 2, 2. And what that shows us for this other graph is that it's the same graph, the same parabola, but it's shifted down 2. Each point is shifted down 2. So when we're talking translations, all we have to do when we see that, when we find the points and we can compare and say, oh, I see what's happening, we just drop down 2, drop down 2, drop down 2. That means we have x squared, the same line or the same graph, the same parabola, and we go down negative 2. So that's the translation downward, translated downward 2. So x squared minus 2. The other one I want to do, I'll actually go to a sheet first because it's easier to see. They want you to graph each one of these on a coordinate plane. You can do that, but I would suggest the table method first to understand what's happening. So I'm always going to choose 0 first. And this is A, this is my given, 1/3 x. And then they give me B, they're adding 1. C, they're subtracting 3. Okay, so when I plug 0 in for x, I have 0 for 3. Since this is a fraction, I'm using that denominator. I'm going to start with a negative 3. When I plug in negative 3, I get negative 1 times 1 is negative 1. If I plug in a positive 3, they cancel out and I have 1. So there's 3 points. I'm good with that. And I can come over here and I can plot those. There's my 0, 0. There's negative 3, negative 1. And then I go over to 3, 1. And there, if I combine them correctly, there is my line y equals 1/3 x. Now, when they're adding 1, you can, once you understand translations, you'll know, oh, it's that same line. I just move every point up 1. And then over here, oh, it's the same line. I just move every point down 3. Until you understand that concept, just plot some points and you'll see what happens. So I'm going to do the same thing, 0. If I plug 0 in for x, I'm left with 1 for y. So automatically I see that the same x value, I have plus 1 in my y area. So then if I choose a negative 3, they cancel out. Negative 1 times 1 is negative 1, plus 1 is 0. I go from negative 1 up 1 spot to 0. If I plug in a 3, my 3's cancel out. I have 1. 1 plus 1 is 2. Same x value, but I just went up 1. Every one of them. Same x value will result with 1 more y. So I'm moving that graph up 1. As far as graphing goes, then you could look at your table and you could graph those points. And now instead of 0, 0, we have 0, 1. Instead of -3, -1, we have -3, 0. Instead of 3, 1, we have 3, 2. We just went up. And I missed it, but we just went up 1. So that's the same thing, but plus 1. And they're parallel. Now we're going to drop down 3. And again, when you understand this concept, you'll see, hey, that's y equals mx plus b. That's the slope. This is a line with slope 1/3. This is a line with slope 1/3 plus 1. This is a slope with slope 1/3 -3. And you start seeing how your y-intercept plays a role here. Okay, so if we just didn't know that rule of, oh, go down 3, go up 1, we can still plot points in. 0 gives me -3. If I plug a -3 in now here, I get -1 minus 3 is -4. And if I plug in a +3 here, 1 minus 3 is -2. I go back to the beginning. Remember, this one we're done with. This was plus 1. Here's my initial 1/3 x. If I subtract 3, now I'm going from 0 to -3, down 3. From -1 to -4, down 3. From 1 to -2, down 3. I'm dropping down 3 points. And we can plot it. We can still take our table and plot those points and say 0, -3, there it is. -3 actually goes down to -4 here, and 3 actually goes down to -2. And what happens is I came all the way down. I dropped down 3. I dropped down 3, but still parallel. 1/3 is our slope. As long as lines have the same slope, they are parallel. They'll never cross. The slope is the same, they'll never cross, means they're parallel. I am just moving them. The translation upward and downward is the +1 -3. Okay, hopefully that helps you understand. I only assigned 1 through 7 odds in this. I just wanted you to do a few to see what translations mean. And then if you encountered a standardized test in the future, in my wife's case, it's elementary ed, and there's a math class, a math portion she needs for the elementary ed degree, and there were many translation problems in there. So you don't know where they're going to pop up, where they're going to show up. I want you to understand what they mean. Okay, I thought that was fun, and that's it for chapter 3.